Hi, my name is Thomas Geesbrecht, and in this session I will explain to you all about user-defined APIs. So, what is a user-defined API? A user-defined API is actually an automation script which is exposed as an HTTP API, and that's on a predefined URL. So you can see like a little example here of a GET request where you can see the hostname z.skyline.be. Then we have a slash, so this is kind of the route. But this part is static, so that has to be always there for a user-defined API, API/custom. And then you have a part that you can choose. So here, db/health. So as the name suggests, you would guess that this API returns the health of your database. That's the kind of ID with this. Now, you can expose these APIs, and you can secure those APIs using tokens. So that's also a very important part of user-defined APIs. And this feature is available since 10.3.6. So you can see the URL path db/health, and then when you trigger it, it will go to DataMiner, run that automation script, and then return you the value that you choose in the automation script. But let's delve a little bit deeper on those three objects that I mentioned. So we have the API script. So this is the DataMiner automation script, which will contain all the logic for your user-defined API. We then have the API token. As mentioned, it will secure your API to prevent not anyone from accessing it. Only the people with the right token, with the right secret, will have access. And then we have the third object, the API definition, and that's an object that actually kind of links those two together. So it just has a reference to the API script and a reference to one or more API tokens, and that kind of defines your API. So let's delve deeper into those specific objects themselves. So we'll start off with the API script. You can see here a little bit of C# code on the left. You have the script class and then the run method. If you are familiar with automation scripts, you will recognize this, since this is kind of the start of your automation script. All the script logic will be included here as this comment suggests. But for user-defined APIs, it's actually a little bit different. It's not a normal automation script. It's actually one with an entry point. So you can see that here on the right is an example of kind of the minimal body of a automation script for user-defined APIs. So the differences are mainly that you have this attribute here. So you can see automation entry point type.types.on API trigger. And also the input arguments are different. So our normal automation script only has an iEngine input, but here we have that and also an API trigger input with the name request data in our case here. And that will actually contain all the information that you need to know: what API has been triggered, what token was used, the body of the API trigger, and so on. And then we also, and this is actually quite new, this was the first time that this concept was introduced, we have a return value for a automation script trigger. So here we have an API trigger output. And in this object, we can actually then return, depending on the logic in our script, to choose what is the response body and what is the response code. So if we delve a little bit deeper again into the request data, so we have talked about the entry point, but here the request data itself, we have a request method. That is whether it's a get, but post or delete. So that's kind of the HTTP REST methods. We then have a route. So this is kind of the thing that I mentioned. So we have the static part, the API custom, and then the thing that you can choose. So this is the same as the previous slide with db/health. So in this example here, we have calculator/add, and that's actually a little nod to the exercise that we'll do in a moment. And that suggests that this API would be like a calculator API where we will add together two numbers. So you can actually get that route there and do whatever you want with it. Then the third is the raw body. So this is kind of the request body that was passed to the API. And that can be pretty much anything that you want. This is just text. So if you want to just return or pass along a basic string, maybe comma separated like a CSV, perfectly fine. If you want to use JSON, if you want to use XML, anything is possible. Since you are in C# code, you can deserialize this information as you like. And then for the output, as I mentioned, we have an output object, and here we have the response body, so we can return something to the user or to the client that is triggering our API. And then, of course, I didn't have like a little arrow for that, but we have a response code as well. So here you can see the response code. and we are returning status code OK. So there's like an enum available with a bunch of interesting or common response codes. So an example of response code is like 404 not found. That's kind of the most famous one. But you have many others like, status code OK is just 200. So if we move along to the next object, so we already have talked about the API script. Let's kind of delve a little bit deeper on the second one, API token. So an API token object is actually very simple. It just contains a name and a secret. So you can actually see this on the right here. There's like a visualization of the Cube UI where you have the name here and then a secret. In Cube, this secret will be automatically generated for you, but you can actually provide your own secret. So if you want, you can use scripting to create these tokens, and that way you can kind of choose your own secret. Maybe you have certain requirements where a secret used in your company or your organization needs to be a certain length, a certain complexity. That's all fine, but it has to adhere to the minimum requirements of DataMiner, which is already quite high. So in terms of the API token, I can also say that the secret itself is actually stored securely in the database. So this kind of text that you see here will only be visible once, and that's actually quite important. So if you generate it via Cube, you will only see it once, and then it will be securely hashed in the database. So even DataMiner itself does not know what the original secret was. So if you lose this secret, you will have to generate a new token and link it to your API definition. It's also kind of indicated here for security reasons. This secret will only be shown now. So kind of treat this as a password, store it somewhere safely, do not share it with just anyone. This is kind of the access key towards your API. And last, I can also kind of share that the tokens can be temporarily disabled. So it's kind of very easy to say, okay, for this time being, this token is actually not allowed, but I don't want to delete it. I just want to disable it for a while. For some reason, maybe you're debugging something, maybe you want to kind of temporarily disable access for certain customers, certain users, certain whatever. You can kind of use that disable functionality for that. So we already talked about the script. We already talked about the token. Now we're going to look at the final object, the API definition. So as I mentioned with the kind of the overview with the three objects, the API definition links everything together. So again, the visualization here kind of is shown as the UI of Cube. So the first item we have is the script. So there you can select your API script. You can have an optional description. It's not required, but I would definitely recommend picking something interesting, something descriptive of your API, since if you have like lots, it may be hard to really differentiate one from the other. The third part is our route. So again, the db/health, and in the code example, we had calculator/add. We have that here again. So you can see host name, the static part, API custom, and then you can choose this. So if you want to create a calculator API where you add two numbers together, we can call this calculator/add. We can skip this little part here. This is kind of a special configuration for certain scripts, maybe legacy scripts, but I would recommend to always keep it on this setting to kind of pretty much say you can do whatever you want. It's a completely new user-defined API script. And last but not least, you also have the token configuration. So it's very important to select the right tokens here. In the visualization in Cube, you will see all the tokens that are available in your DMS, and you can select all those that should have access. And you also have a button to create a new token there as well. So that's pretty much it for the kind of explanation of what user-defined APIs is all about, the three different objects. Let's actually create one ourselves. If you want to do this hands-on yourself as well, you can follow along at home, but you will need two requirements. So first of all, you'll need Postman. So Postman is an API testing tool, and you can quite easily download this via this URL. If you have other API testing tools where you can send API requests, that's also perfectly fine. Postman is one of the more common ones, and you can try that one out. If you download it, it may ask you to log in. You can just click try a lightweight client or something like that, like without logging in. It's actually recommended if you're not planning on really using Postman all that often. That will be easier for you. So that's kind of the first requirement. So pause this video and go install Postman if you want to follow along. Once you have downloaded Postman, you can deploy a catalog package. So for this kind of example, we'll need the user-defined API calculator API tutorial catalog package. So you can go to catalog.dataminer.services, search for user-defined API, and you should see this package and deploy this to your DataMiner agents. You can actually follow along as well without this package. If you are not cloud connected, you can actually just kind of also create an automation script, but you'll need to do some kind of typing there to get the basics started. All right, so I have Cube open right now, and I have deployed the catalog package. And if you open up the automation module in Cube, you can actually see that there has been a folder here, Empower User-Defined APIs. And if you go a little bit further down inside that folder, you can see the calculator API script. So this is our automation script that we will deploy or kind of expose as a user-defined API. So when you open up that script and scroll a bit down to see the code, you'll eventually see the onAPI trigger method right here. All right, so this is kind of the entry point, the trigger of our API, where our code will start. So you can see, as I've shown in the slides, that the input arguments are engine and the API trigger input. So we have our request data here, and the first thing that we're going to do with the request data is pick out the raw body. So this is the raw body that was passed along, and we're going to split it on the comma character. So what we expect here is that we have a kind of a collection of two strings or more strings, depending on how many numbers that you pass along. And then the next thing that we'll do is we'll start validating our input. So we're going to check, did we receive exactly two numbers or kind of two strings? If that's not the case, we're going to return an error. And we do that by just returning a new instance of the API trigger output class. And then we have our two properties, the response body and the code. So the body will kind of have a meaningful message. Yet you can only have two numbers separated by a comma character. And then the response code we're going to choose for bad request, since the request itself was not entirely correct. And since there's a return statement here, it will quit the script, and then the client or the user or whoever is triggering the API will get this response. If there are, however, two scripts, then we will kind of parse them. So we have two parse methods here. So we do int.tryParse, the first number and number 1. If that does not work out right, we're going to do the same. So we're going to return an API trigger output with a meaningful message again, could not parse number x to a number, and again, bad request, and we'll do exactly the same for the second number. So at this point, we have two actual integers, numbers that we can add up, and that's what we're going to do in this kind of last step here. We're going to take the parsed version of number 1, the parsed version of number 2, and we're going to add these up together and put it into a result. So actually the logic is very straightforward, very simple. It's a bit of a basic calculator that we're just going to create as an example. So once we have the result, so this is also an integer, we're going to just return that as a string. So as a last statement, we have return new API trigger output, just like the others. But here we're not going to return kind of an error, but we're just going to return our value. So result.toString. And then we're going to say the request was processed correctly, status code.ok. So this will be a 200. So that's pretty much the logic of the script. So it's quite straightforward, but let's kind of expose that, or let's create an API for this. There's actually two ways how you can create a user-defined API in Cube. The first one is here with the configure API button. That will open up the UI and kind of create an API definition for this API script. But you can actually do it via the System Center as well. But I will show you that in a moment. So when you click on Configure API, this kind of now familiar API creation window will pop up. And we can create a description. So we can add like, will add up two numbers. Quite simple. And then the next one, and actually one that is required, is the route. We are creating a calculator API which will add up two numbers, so we're going to choose for calculator /add. And then we also need a token, of course. So you can click on the new token button over here, and then it will ask you for a name. This is not mandatory, you can just leave it empty and it will just generate a name for you, but let's use presentation token. and then click on generate token. So this is the token that you will have to use, of course, is the secret, more to say, that you will have to use to trigger our API. So make sure to copy this and kind of also store it securely. If you're doing this like on a production system, definitely make sure to store it securely in a password manager, for example. You don't want to lose it or get it given away to people that should not have access to your API, of course. So once you've done that, you can click copy and close again, so it will make sure it's copied to your clipboard. And that's pretty much it. The only thing that kind of remains to do is click on the create button, since that will create our API definition. And there we go. Our API has been created. And you can actually see that. So if you look here at the calculator API script that we have, a new icon popped up. So this little man icon with a little lightning bolt kind of indicates that this is a user-defined API. So you can actually also view these user-defined APIs in System Center. So if you click here on your user icon and then go to System Center, you can actually see these as well here in the user-defined APIs section. So if you click on that, you will have two tables. I will close this one. You can see the two tables that will list all our APIs. So these are the API definitions and then all our tokens as well. And it's actually here that you can disable these easily. So if you just simply right-click on a token, you can disable them, and then it will kind of say, are you sure? Yes, and now it's disabled. So this token cannot be used anymore right now to trigger any API. So let's enable it, since we'll use it to demonstrate it in a bit. So we can correctly see that our calculator API script has been kind of used for the calculator add API, and you can also see the description here as well, and a list of tokens that have access to it. So let's try it out if it actually works. If you open up Postman, you should see this page. At least if you use a lightweight client. If you use a logged in version, it may look a little bit different. But let's get started with triggering our API. And the first thing that you'll need is our URL. I'm using a DAS, so I'll go to dataminer.services to get my URL. So you can actually see it here. So I am on dataminer.services. I have my organization selected and my DataMiner as a service agent. You can actually see it here. And this is the URL that I need. So I'll just simply copy this and then paste it here in the URL bar. That's the first part. Now we need the kind of the static part that I already mentioned. So that's the API/custom. It's already kind of suggesting the one that I'll need. And then we need the part that we've chosen for our API definition. So we have chosen there calculator/add, and that's it. So that's the kind of full URL that we want to use in our HTTP requests. On the left, you can also choose the method, so get, put, post, and so forth, but that doesn't matter for our kind of example. You can just leave it on get. So we can actually already give it a try, even though we have not finished the configuration yet. So if we send the requests, you can see that we get an error. So you have a 401 unauthorized error. And the title of the error is, error occurred while handling the requests, contact your admin with provided error codes. And then the detail of the error says, supplied token is invalid or is not allowed for this API. So it's kind of saying, okay, you want to trigger a user-defined API, but you actually have not authenticated yourself, you have no idea who you are, you have no access to anything. So it's asking to provide a token. So let's add it. You can actually do that by going to the authorization tab over here. And then you need to select in this list of possible authentication systems, of authorization systems, you have to select a bearer token. That will open up this little window here with a text box. It may already contain something, you can just clear that. And then you can paste your token. So that's the token that was generated in Cube a little earlier. So, okay, we have provided our token. Let's hit send again. And here we have another error, but it's not in a different way. So it's not an error coming from the user-defined APIs feature in DataMiner itself, but it's actually coming from our kind of our API script. So this is the error that it says, you need to provide two numbers with a comma separation. So also let's do that. Let's fix that. So in that same kind of tab here, or the tab header here, let's choose for body. We select the type raw, and then we can leave text. And here we can choose two numbers. So let's keep it simple. We'll just pick 1 and 2. So if we hit send, we would expect that we get 3 back. So let's give that a shot. And there we go. We have 3 back. So this kind of confirms that our API is working as expected. We can actually try maybe a few other of our validation steps that we have done. So let's provide two things, but it's actually not numbers. So we have a 1 and hello. If we send that, we get back, I could not parse hello to a number. So that kind of also proves that our validation steps work as expected. And you can actually also see here at the bottom the 400 batch request kind of status code that is returned as well as we were intended to do in our script. If you like this exercise and want to do some additional extensions on top of it, you can go to the URL, which is pictured here, so aka.dataminer.services/UDA-advanced, and that will guide you to a GitHub repository, which will contain some additional exercises. So be sure to check those out if you want to kind of continue and use some advanced or more advanced features. If you want to earn some DevOps points as well, you can do so by doing exercise number 2. And this is where only GET requests are allowed. So right now it doesn't matter which kind of type of request, a POST or a GET or a PUT or whatever, is sent towards our API script. We just allow any, but you can extend your API script to only allow GET. So that kind of you will need to check the kind of the request type and then have to do a check and return an error. So if you have done that, you can actually send a submission or upload a screenshot of the Postman output where you can see the error response if you send a POST or another type of request than a GET. You can submit that on DataMiner Dojo. If you scroll down, or you should see this kind of assignments uploads section. If you are watching this on YouTube, check the description. You will see also some information on how you can submit your screenshot. To close the session off, let's talk a bit about the performance. In general, we recommend to avoid long operations. So if you have like a certain action that takes a very long time, we recommend creating two APIs, one that triggers that long action, and then it returns some kind of identifier. And then you have a second API, which can be used to kind of poll or monitor or get the status of that action. So otherwise, you may have an action and your API request is like taking minutes or so, or even more. That's generally recommended to avoid that situation. It's best to aim for like in the milliseconds range to trigger your API. A general thing to keep in mind is also to avoid very large request and response bodies. The user-defined APIs feature supports up to 29 megabytes of data, but we generally recommend to stay far away from that and only kind of send in the kilobytes range, because that will also have a negative impact if you send too much data towards your API. Here on this kind of slide, you can actually see a bit of a representation of how the user-defined API system works. So in the middle, we can see our HTTP API requests, and if we send that to DataMiner, it actually does not get sent to the core of DataMiner, but it gets sent to an extension module. So that's a kind of a separate process which extends the core of DataMiner with this DataMiner user-defined APIs feature. And what it will actually do is it will receive your request, it will do some basic validation, and then it will send it to one of the DataMiner agents in the DMS. So it's very important that you keep that in mind, since it does not mean that if you send it to DataMiner A that it will actually be handled, like the API script will be executed on DataMiner agent A. It may be executed on any of the agents in the cluster. This is actually a load balancing feature, so that allows you to send significantly more API requests to a certain node, but all the load will be automatically shared across the whole DMS. There is a limitation on the amount of parallel requests. So this is based on the amount of CPU cores that you have. So on the DataMiner agent itself, there is a limitation that will kind of limit the amount of API triggers that can be ongoing at one time based on the amount of virtual CPU cores that you have. So you can actually increase the amount of kind of capacity by just adding another node, and then you will have additional parallel handling capabilities. Now, performance itself. Some people ask me, but how fast is it? How quickly will I be able to trigger our APIs? And that kind of is a bit of a hard question, since it depends on so many factors. It depends on the internet speed, it depends on the script logic, it depends on the hardware where the APIs are running on, and even the other load on the system at that time. So it is a bit difficult to kind of say one specific number, but we have done some testing on a kind of a single system to get a kind of a worst case scenario if you don't have the capabilities to load balance it across the whole cluster. And we have kind of noticed that kind of a realistic maximum is 100 triggers per second. So that's already quite fast, but you can increase that by increasing the amount of agents in your cluster. And even you could share the load across multiple of these endpoints as well. So multiple of these extension modules by sending some requests to one agent, the others to the other, and so forth. To completely round up the session, I just want to highlight the documentation for our user-defined APIs feature. We have put an extensive amount of time into creating as clear as possible documentation with everything you'll need to work with this feature, debug it, and so on. So the page that I would definitely recommend checking out and being aware of is this error codes page. So actually, I'll show you this page. So if you click on it, you see that we are in the user-defined API section on the triggering an API page. And the error code section explains all the different error codes that can be returned by DataMiner. I can actually demonstrate again if we go back to the Postman app, and I'm going to break my token. So I'm going to remove a specific character. So I will expect that we get an error back. And there's actually two things that are very important in terms of errors. So we have the error code here, and this is the one that I have in the list on the page. And we also have the faulting node. And this faulting node is the DMA ID of the agent where it went wrong. So I explained to you that the triggered API won't automatically be executed on the agent where you send the request to. It may be executed on other agent. But yeah, if you want to kind of debug, kind of know what went wrong, if that API trigger failed, then you can use this faulting node to know which DMA to kind of look at the logs and so on. So this error code 1010, let's check out our table. And if we scroll all the way down, you can see here that it says authentication failed. So there's a little description that kind of suggests that the token was empty, invalid, disabled, and so forth. This is actually quite generic kind of description because the exact reason why the token failed is kind of obfuscated a little bit. And that's actually for security reasons. We don't want an attacker to kind of know, okay, this token exists, but it's not allowed for this API. I'll try to use it for another API, and so forth and so forth. So it's kind of generic to say, yeah, your token is not right. What exactly is wrong with it? We're not going to tell you. But it's actually kind of visible in the logging of your agent. So if we go to the logging of our agent, DataMiner, and then we're going to pick the user-defined API manager. There we go. I'll close our system center. So then you can see that there's a log line here, which says that our API trigger for the calculator add was triggered, and that it failed after 0.88 milliseconds. And the reason why is that no API token was found that is linked to the provided secret. So this kind of more specifically tells you the API was triggered, but the secret which was passed is actually not linked to an actual secret, so or an actual token. So there's no token that exists with that secret. So it's already a bit more descriptive than what you had in the description on the page with the error code. There's even more pages that are very interesting. For example, the troubleshooting page. When something is wrong, it will actually kind of explains the whole node thing as well. And we also have the tutorials section, which also includes some additional kind of examples and tutorials that you can follow to play around with the user-defined APIs feature. There's actually also a kata available on the user-defined APIs feature where Jan and I created a user-defined API to trigger a certain kind of maintenance light and also put some elements in a maintenance mode. So definitely be sure to check that one out if you are interested. So I thank you very much for watching this video. I hope you found it interesting, and I see you in the next one.